So natural extension is 2 power 3. Okay. So these are the experiments which you will be typically using as a trial. Okay. 8 factors. Okay. How many two-way interactions? There will be two bilinear interaction as well as trilinear interaction. How many bilinear interactions I will have? Tell in terms of combinations, do not tell me AB, BC, CA, that is 3C2. Okay. 3C, 2 bilinear interactions, 3C3 trilinear interactions. Okay. So there is 3C3 is just 1, so there is 1 trilinear interaction and 3 bilinear interactions. Okay. Now imagine if I have to start doing, if I have to write, ask you to write about without contrast, every time if I asked you to compute, what will happen? Pain. So once and for all you do this contrast term, fix the contrast, job is over. So what is the effect of A? How do you compute effect of A? Main effect of A. Now you understand why y bar A plus and y bar A minus is required. What is main effect of A? How do I write main effect of A? Main effect of A is nothing but when A is positive, average when A is positive minus average when A is negative. Now we did not use y bar A plus at all during 2 power 2 experiments, because that is very simple. Okay. And only 4 experiments, what is y plus A? It is, you can write it there. Actually if you go back to 2 power 2 also it will be the same. Okay. Y bar A plus minus y bar A minus I could do in 2 power 2 also. First line itself I could have done, right, but that is very simple, even without doing all of this you can write. But here you have to come back and stand your ground and say, look, when A is positive minus A is negative is what my net effect of A. How many terms will have A positive? Go back, look at the A positive terms, there are 4 and A negative terms 4. So totally all 8 coefficients are involved. So it is a pretty straightforward. See, some books will take you for a ride by constructing a cube. If you look at it geometrically, it will become a cube, and your 2 power 2 experiment is a square. Square is easy, cube will become difficult, right, it will become a slightly complicated, and the diagonals will play something important, off diagonals will play something important, etc. Okay. In fact, if you go and look at it geometrically, the diagonals will give you the easier route to compute interactions. Okay, I will leave it to you for think about. Okay. So this is my effect of A, pretty simple, go by this A plus and A minus, that is all. And similarly, so you can write the contrast. Similarly, I can write it for B and what? C as well, very simple. Now once the table is there and once you know what is effect, y bar A plus minus y bar A minus, y bar B plus minus y bar B minus, y bar C plus minus y bar C minus, all the contrast can be written. How do I write it for two-way interactions? How do I write it for two-way interactions? See, look at two-way interactions, I do not have any zeros. Look at the contrast, I do not have any zeros at all. Clear? A I have 8, B, AB, C, AC, BC, ABC. I do not have any zeros at all. So how do I write interaction, contrast AB interactions now? What is it? Can we write? Is it AB given C plus minus AB given C minus? Huh? AB given C plus and AB given C minus. Then what is ABC? ABC is what I would say AB given C plus minus AB given C minus, right. What is then a interaction AB? Huh? You want to write combinations. If you write combinations, how many terms will you get? AB, A plus B plus minus A minus B minus. How many terms A plus B plus is there? How many total terms A plus B plus is there? 1, 2 terms. A minus B minus? How many data points you have effectively used? How many contrast terms I have? 8. So I have not computed the way you have seen, right. This is the same way you are telling about A plus B plus minus A minus B minus. That is one way of doing it, right. You understand what you were saying? You were saying, compute A plus C plus minus or A plus B plus minus A minus B minus. That will essentially involve only 4 data points. But in my equation in here for A, B, I have all 8 terms involved without any zeros. So can you think how did we get this? Please go and check AB interaction in a 3 and what is AB interaction actually? Probability of or effect of A given B plus minus A given B minus. Now how do I this is when only 2 factors are involved. How do I include C also in picture? Should I include C or should I not include C? I have to obviously include C. What is the condition? Then you have one more conditional probability. Is it A given B plus and C plus minus A given B minus C minus? Okay. This is given C plus minus whole thing given C minus. Slightly tricky, okay, but that is how it is. If you want to use all the 8 data points, which is what is natural because you want to make it as robust as possible, okay. So go expand on this, try getting your contrast terms for AB, BC, CA, okay. And ABC is pretty simple. I have expanded AB given C plus minus AB given C minus, okay. So that we can go about and do it wherever AB is positive, okay, and wherever AB is negative given C plus and given C minus, clear. So that is my ABC interaction. So once the contrast are done, it is again as the contrast table. So the effect is straightforward, okay. So this is 2 cube by n, 8 by n, this is the sum squared effect. Sum square effect is the same, instead of 4 by n now you have 8 by n, 2 power 3 by n, okay. Let us not worry about variance etc and t distributions, I have not taught you this, so let us not worry about this, okay, but sum square effect is straightforward. Once you have sum square, you have the what I said, the fitted model also. The fitted model, how many coefficients you will have? There will be 1 grand mean, 3 treatments, how many interactions? 4 interactions, 4 plus 3 plus 1, 8 coefficients, okay. So now you should understand how many data points are there, 8 data points are there, how many parameters you are estimating? 8 coefficients, which is the most stupid thing to do without replication. You have 8 parameters, you are estimating 8 data points, you have 8 data points and you are estimating 8 parameters, and that is the reason why sum square error has no degrees of freedom. So a replication is mandatory, otherwise you have 8 parameters, you have 8 data points, you are fitting every parameter data point, right. So that is why this will not work out with replications, without replications. A replication is mandatory if you want to fit all the parameters. If you want to fit all the parameters, replication is mandatory, because there are only 8 data points and you are asking for 8 parameters, which makes no sense. okay, unless you have more data points replications, and all the fx are again divided by 2. So the parameters are nothing but fx divided by 2, so same as 2 power 2, okay. So that is why this 2 power 2 and 2 power 3 pretty easy when you learn 2 power 2, it is an extension 2 power 3, and the only one equation becomes important, the fx equation. Once you know the fx equation, everything is straightforward. This is the only equation you should know about. Once you know the fx equation, everything else is straightforward. Clear?